All right, welcome back to the deep dive. Today we're getting into a specific piece of hardware, and it tackles this really persistent and frankly expensive hurdle in professional AV installations, the network itself. Our mission is to figure out how this thing, the Blustream IP50HD-RX receiver, pushes HD video and full control signals over a standard 100 megabit network.
That's the whole game right there. I mean, this device is your entry point into AV over IP, but without demanding a whole new infrastructure. And the magic, really, is the HW265 compression.
Yeah.
That's the codec that lets quality 1080p video, live comfortably on that limited network. You can push it up to 100 meters over just one CCAT cable. It's built for installers.
Okay, so that right there simplifies things immensely. So let's talk flexibility then. Every job is different, right? So how does it adapt? What are its modes of operation?
It has two, and they're both crucial. For your bigger installs, lots of sources, lots of screens, you use the matrix distribution mode. That relies on a managed 100 meg network switch. But if you just got a simple point-to-point job, you can use the one-to-one HDMI extender mode, no network switch needed at all. And both will push a solid 1080p 60 Hz signal.
That makes a lot of sense. But what about responsiveness? Latency is always the big question with compression. They're claiming 3 frames, so under 120 milliseconds. For a compressed signal going through a switch, is that a number an installer can really count on?
It is the critical number, yeah. And look, that figure is subject to the compression and any scaling that the display has to do. It's a trade-off. It has to be. You're optimizing for limited bandwidth, not for, uncompressed zero latency video.
Right. A necessary trade-off. Okay, so latency is one thing, but another huge headache for installers is just mixing and matching displays. You never get a job where every monitor is the same.
Oh, it's a nightmare. And this is designed to be a problem solver for exactly that. It has a video scaler built right in. This means you can have a new 1080p source feeding an older 720p display in the same system, and it just works. It's all about advanced ED management. That's the digital handshake that gets all the devices to agree on a signal.
So it's way more than just a video box. It sounds more like a central control hub, especially when you see KVM support mentioned. What other signals are we talking about here?
A whole suite. You get bidirectional IR, RS-232. But the critical part, and this is really powerful, is that you can route the IR, the RS-232, and the video and audio all independently.
Wait, hang on. Independent routing. So the video can be going to one screen, but the RS-232 control could be sent to a completely different device on the network.
Exactly. It's incredibly flexible for automation. And then you have the KVM part, which is handled by 2 USB ports for your keyboard and mouse. As for power, it mostly uses PoE power over Ethernet. Draws less than 3 watts, so you just power it from the switch. Super clean. And for audio, it's PCM 2.0, but you do get a handy analog audio breakout on a Phoenix connector.
So when you put this all together for you listening, what you have here is an incredibly powerful tool. It's a flexible way to extend high-def signals, sure, but it also consolidates all that control, dash KVM, IR, RS-232, all on a network you probably already have in the walls.
And that leaves us with a really important question for you to think about. This device works its magic, using HDTVSupply compression to fit onto that 100 Mbps network.
So what are the inherent trade-offs? I mean, in terms of maybe a tiny bit of latency or some minor visual artifacts you might not even see when you compare it to a massive uncompressed 4K AV over IP solution that needs a 10 div network. It really highlighted the critical balancing act in AV engineering today.